Hi everyone. I know that you were working on the yellow packet yesterday and today in class, so I wanted to go ahead and do some of the examples on the yellow packet here. Okay, in the very front of the packet there is a factoring flow chart. This is to guide you through the methods that we've used so far when it comes to factoring. Okay, so whenever you're looking for something, you always want to first see if there's a GCF. The benefit of a GCF is that if there is something to make our values smaller, this is where it's going to be where we're going to find it. Okay, so then our math won't have such large values to be worked with. Okay, so if there's a common factor, always take that GCF out. Once you've taken out a GCF, then I want you to check to see if there's 2 terms, 3 terms, or more than 3 terms. So what type of polynomial is it? If it is only 2 terms, then I want you to check to see if it is a difference of squares, if it is the sum of squares, if it's the difference or sum of cubes, okay, which means something to the 3rd power. And if it is, then we're going to be looking at these different methods. So if it's a difference of squares, we're going to be using this shortcut here. Okay, this is where we're just going to find our A term, find our B term. First, we're going to subtract them, and then we're going to add them. Okay. If it is the sum of squares, so if A is a perfect square and B is a perfect square, but they're being added together, then we're just going to write prime. They cannot be factored. Okay, that would be our simplified value is what it already is. If it's a difference or sum of cubes, this is when I gave you guys that video on soap. Okay, or when we sang that Christmas song where we talked about that we find the cube root of the A term, the cube root of the B term, and then we write it out with our shortcut formula here. Okay. If it's 3 terms, so maybe it's not 2 terms, maybe it's a trinomial, is it a perfect square trinomial? And if you're not sure whether it's a perfect square trinomial or not, then you can always just go ahead and use the methods for factoring, like the diamond method or the quadratic formula or completing the square. Okay, so that's where we're going to look at if it's 3 terms. Quadratic formula, completing the square, and I'm going to go ahead and put the diamond here because that is something that we work with. Okay. All right. If it's 3 terms, we'll factor that. Okay. Let's see. And if it's more than that, then we are going to be looking at a polynomial with 4 terms. And in that case, we are going to be doing factoring by grouping. Okay. No synthetic division on this first part or the second part, but we are just going to be working on the factoring one. All right. Here I've just given a quick example of what distribution is. Distribution is when we multiply something in, and factor is the inverse of that, where we divide something out. All right, so factoring each polynomial. So let me go ahead and just get started with this one. First off, is there a GCF? Is there something that all 3 of them have in common that I can divide out? And there is not. Okay, so now it's not 2 terms, so it is 3 terms. And the first thing I'm going to think of is if A is 1, I'm going to use our diamond method. Okay, and in this case, the A value is 1. Ooh, that's not what I want. A is 1, B is -2, and C is -15. Okay, remember we did talk about you can always use the quadratic formula. If you're somebody who likes the quadratic formula, by all means go ahead, but we practice the quadratic formula more when we were talking about solving. Okay, and this right now we're just factoring. So let's go ahead and just use the diamond on this one. I know it's been a little bit since we've done this, but let's go ahead and go with it. Okay, first off, A times C, 1 times -15. That adds to B. Okay, so what 2 values is that? I'm going to say -5 and +3. Okay, so I'm going to now and replace -2x with negative 5x and positive 3x. So we're still going to have x squared, negative 5x, plus 3x, and then negative 15. Now that we've got 4 terms, we're going to go ahead and factor that by grouping. So I'm going to group together the first 2, group together the last 2. Remember, these 2 pieces are still being added together. Okay, there is still an addition sign in the middle of them. All right, so the first 2, what do they have in common? Where does their GCF? GCF is x, and I'm left with x minus 5. And the second group, their GCF is positive 3, and I'm left with x minus 5. Do the inside groups match, or do the factors match? Yes. So then my first factor will become what's on the outside. So x plus 3. And my second factor is what they're both being multiplied, or what's on the inside, x minus 5. Okay. So those are my factors for number 1. Okay. All right, let's go over to number 2. Number 2, when I'm looking at this one, there's 2 terms. So the first thing I want to do is to see if the a term and the b term are perfect squares or perfect cubes. Okay. First off, I want to do that what I said we were going to do first and see if there is a GCF. Is there some number that they can both be divided by? Well, 81, can it be divided by 16? No, we cannot. But can 81, because I'm looking at 16, 16 can be divided by 8, 81 can't be divided by 8, 16 can be divided by 4, so can 81 be divided by 4? Nope, it cannot. So in this case, there is not a GCF that I can find to make those values smaller. So I'm going to go ahead and look at, is there a perfect square value to the first term and to the second term? Let's see. My a term, perfect square, the square root of 16x squared would be 4x. And for the b term, square root of 81 would be 9. Okay, so since they are both perfect squares and they are the difference of squares, the shortcut that I can use here is I'm going to have 2 factors. They're both going to have the a and the b, so they're both going to have 4x and 9. The first time we're going to add them, second time we're going to subtract them, or subtract them and add them, and those are our factors. Okay. All right, let's go over to number 3. On number 3, is there a GCF? Is there anything I can divide out of both terms? Because I can see that they are being subtracted, so this is going to be a difference of squares if they are perfect squares. All right, so GCF, 24 and 54 can both be divided by 6. So I know I can factor out a 6. They both have at least one x variable, and they both have at least one y variable. So factoring out that GCF, I'm left with 4x squared minus 9. Okay. All right, now looking at the factor, the group on the inside, that there is still a perfect square trinomial. So, I'm sorry, perfect square binomial. So on this one, the a term would be 2x. The b term would be 3. So I would have 2 factors. One's going to be added, one's going to be subtracted. I will have 2x plus 3. We'll have 2x minus 3. And this 6x squared, or 6xy, is still part of our equation. It was just the GCF. So it is still there, okay? Now I look at that just to make sure there's nothing I can factor even more, which I cannot. So this would be my solution, okay? All right, let's go on to number 4. Number 4, I have two terms. Are they a perfect square? No. Are they a perfect cube? Yes. The cube root of x to the 8th would be x squared. Okay. And the cube root of 1 is 1. Okay. There's the difference. So thinking about that soap song, the Christmas song that we sang, we said we're going to take the a value, subtract the b value, take the first term and square it, add it to 2 times a times b, and then always add the last term squared. All right, so we have x squared minus 1. So then the a term being squared, so x squared times x squared gives me x to the 4th plus 2x squared times 1 plus 1, which is 1 squared, it's just 1. All right, so then simplify that. X squared minus 1, x to the 4th, and plus 2x squared plus 1. Okay, so we've written that out because it is a perfect square trinomial. I need to look, though, to see if there's still anything that I can still factor. Can I still break it apart even more? Okay, looking at these two, that is the difference of perfect squares. So that looks just like what we did on number 2 and number 3. Okay. So those two there. Now the a term is x. Just looking at that piece there. The a term is x. B term is 1. Okay. I have a plus and a minus. I'm going to have x plus 1 and x minus 1. And looking at that trinomial here now, got to see, can we factor that? Is there anything that would multiply to 1 and add to 2? Okay. I'm running out of room here. So let's see. Is there anything that we can see that would multiply to 1 and add to 2? Yep. There would be a 1 and a 1. Okay. So we would have x to the 4th plus 1x plus 1x plus 1. Okay. Group together the first two, group together that last two. Remember, they are being added. So I still have this x plus 1. I still have this x minus 1. First group has an x. And I'm left with x to the 3rd plus 1. And I'm left with 1 times x plus 1. All right, let's see. These do not match, which tells me that it's probably not factorable. So since it's not factorable, then I cannot break it apart. So I don't need this step. I don't need this step. And that this here would be my final solution. All right. Let's go over to number 5. On number 5, I want to first look to see if there's a GCF. Is there anything that we can factor out? Yes, in this case, we can factor out an x squared, and we can factor out a y squared. So then I'm left with x squared minus 4 times x minus 12. Okay. Looking at this trinomial here, a is 1, so I'm going to go ahead and use that diamond method. What multiplies to negative 12 and adds to negative 4? Okay, well, that would be 6 and 2, and it would have to be a negative 6. So we would have x squared minus 6x plus 2x minus 12. Group together the first two. Group together the last two. Remember, they are still being added. Okay. And first group, we can factor out an x, so that I'm left with x minus 6. And the second group, I can factor out a positive 2, and I'm left with x minus 6. The insides do match, so we've got x plus 2, x minus 6. Okay. And in the very beginning, we factored out that GCF, so that GCF is still there. I don't need it in red, though. I want to keep it in blue because it's part of my final answer. So then we had x squared, y squared, x plus 2, and x minus 6. Those are our factors, just for factoring on that one. Okay? All right, let's go over to number 6. Okay, 4 terms here. It's going to be factoring by grouping, and I think I'm going to start you off, but I'm going to skip this one because I want to go to something that I think we might need some more practice with. Let me go ahead, show that we're grouping those two. Remember, they're being added together, so you're going to look for the GCF for each of those. Okay. Number 7. Same thing on this one. I'm going to get you started. First thing you need to do is look for a GCF. They can all be divided by negative 3, and they all have at least x squared. Okay. So then you would be left with x squared. Now it's going to be a negative 10 because we factored out a negative 3. And it's going to be a positive 25. Okay. So this here is your GCF, but use the diamond method or quadratic formula if you'd prefer, and go ahead and factor that one. Okay, factor what's inside, and then at the very end, remember to still attach that GCF to it. Okay. All right, number 8. All right, let's look at this one. Is there anything here that can multiply to negative 24 and add to negative 10? Okay, that's what I want you to look at. If you can't do that, or if you want to, if you prefer the quadratic method, go ahead and use a quadratic formula. Go ahead and use that. Okay. All right, number 9, it's 4 terms. So we're going to go ahead, group together the first 2 terms, group together the last 2 terms. All right, first one, they have x to the 4th in common, and then we're left with 5x minus 10. The second one has x squared in common. Also has a 5. They can both be divided by 5. So then you've got 5x minus 10. Okay. Do the insides match? Yes. So our first factor is x to the 4th plus 5x squared. The second factor is 5x minus 10. Okay, now looking at this one, that first group, that first factor still has things that can be factored out. So here I can still factor out an x squared, and then I'm left with x squared plus 5. Looking at this factor, I can still factor out a positive 5. And then I'm left with x minus 2. When I look at these, though, the inside doesn't match. So I'm not going to be using, well, I'm not using factoring by grouping anyhow, because they weren't being added together here. Remember, I always say if they're being added together. In this case, they weren't. So on this one, I'm just trying to see if there's anything. I'm going to go with x squared, because that could be factored out. And I'm left with x squared plus 5 and 5x minus 10. Okay. All right, that's my solutions for factors on number 9. All right, let's go down to number 10. Using the diamond method, is there anything that can multiply to negative 10 and add to negative 30? Because 3 times negative 10 is negative 30, and add to negative 13. Okay. All right, looking at number 11, first off, is there anything we can factor out? Yes, they can all be divided by 3. So then we're left with x squared minus 5x minus 16. Oh. All right, so then looking at that one, we've got, why in the world do I keep changing pen color? Okay. See if you can find two values that multiply to negative 14 and add to negative 5. Okay. Same thing on number 24, hold on. Nothing that we can factor out. This would be a very large value, but you wanted to see if you want to do, is there anything that could multiply? You would take 24 times 15. Is there anything that can multiply to 360 and add to 2? You can check all those values. I'm not telling you not to. What I'm going to go ahead and do, though, is use this as an opportunity to do the quadratic formula. All right, so on this one here, remember we do the discriminant first. Okay, so b squared minus 4 times a times c. Okay, so we've got a negative times a positive. 4 times 24 is 96. Okay. And then once we have that, we've got to also multiply it by 15, negative 15. Okay, so that gives me positive 1,440. So my discriminant is 1,444. Okay. Now we want to look to see if we can find the square root of that value as part of the discriminant. We know there's going to be two solutions because it is a positive number. Remember, if it was a negative number, there'd be two complex solutions. Okay, the square root of that is 38. Okay, so now looking at the quadratic formula won't be so long. X equals opposite b plus or minus the discriminant all over 2 times a. Okay, so this is where we said we have two problems. We've got -2 plus 38 divided by 48. Ouch. And then we've got x is equal to -2 minus 38 over 48. Okay, now this is going to give us the solutions, which we are looking for the factors. So here, though, -2 plus 38, okay, that's going to give us 36 over 48. We can reduce that, and once we reduce that, we got x equals 3 over 4. Okay. On this one here, we would have x equals -40 over 48, or x equals, both of them being divisible by 8, would give me 5 over 6 negative. When I move this back to this side, the factor would be x minus 3/4, and the other factor would be x plus 5/6. Okay. Now, this on the third page here, where it asks you to solve it, this is your solution. But when they're asking us for factors, we're looking for what were they multiplying. Okay. All right.